Okay, good to go, Nikhita?
Sure.
Okay, I'll give you an introduction. Hi, everyone, and welcome to today's SAO colloquium. We're lucky to have with us today Nikhita Madhanpall, who's a fellow working for DARA Big Data at the Office of Astronomy for Development. So Nikhita has a PhD in astronomy from the University of the Western Cape, and she's also spent the last couple of years working at the South African Radio Astronomy Observatory. So Nikhita, I'll leave it to you to tell us more about the DARA Big Data Hackathons.
Okay, great. Thanks, Vanessa. Okay, morning, everyone. My name is Nikhita Madhanpall, and I'm a Big Data Fellow at the Office of Astronomy for Development, based at the SAO in Cape Town. And I'll be talking about data science skills development with Big Data Hackathons. So these hackathons are a collaboration between 3 partner institutions. DARA Big Data, DARA stands for Development in Africa with Radio Astronomy. And this project provides support for students from the 8 SKA African partner countries in order to develop their skills in data-intensive research. And we have IDEA, the Institute for Data-Intensive Astronomy, whose goal is to build capacity and expertise in data-intensive research. And obviously they also, in terms of the hackathons, they provide access to their data-intensive research cloud facility, ILIFO. And the OAD, of course, Office of Astronomy for Development, where we make use of various aspects of astronomy in order to aid the sustainable development goals. So how do these hackathons fit into the work of the OAD? So the OAD has identified areas of astronomy development, which we've called flagship themes, and with the idea being that projects will be developed under these flagships and implemented on a much larger scale than the projects that come out of the OAD's annual call. So one of these flagship themes that have been identified is using the knowledge and skills from astronomy to aid development. So in terms of the hackathons, the idea is to, if you provide exposure to people with of these skills that are commonly used in astronomy, like data science and machine learning, that students and young professionals can then either apply these skills to their research going forward, or perhaps continue to study further in these fields. And the hope is that this would lead to better job opportunities, which would aid socioeconomic development. For the hackathons, like I mentioned, we're also making use of infrastructure, so computing infrastructure that was developed for astronomy, and it's now being used to aid development. In terms of DARA Big Data, they also have sort of focus areas or themes around big data, and that's big data astronomy, big data projects in health, and agricultural big data projects. So, for example, in health, using big data to improve sort of diagnosis efficiency for things like detecting malignant tumors. So radiologists making use of these kinds of things, skills, and then also using things like remote sensing in order to assist agriculture, assist in terms of precision farming and sustainable agriculture, and optimizing crop yields, etc. So these are the 3 focus areas of DARA Big Data, both in terms of the projects which they fund that their students are working on, as well as the projects that the hackathon projects are usually developed around these themes as well. This is the team responsible for putting together these hackathons. You'll recognize a few faces, of course, myself, Vanessa McBride, Kevin Govender from the OID, Carolina Odman-Govender from IDEA. We have Anna Scaife, who's the DARA Big Data Project lead, and Lindsay Stirrup, the DARA Big Data Project Manager, both from the University of Manchester, and Jeremy Smith from IDEA, who provides technical support and puts together all the resources that are necessary for the hackathons. So what are we trying to achieve with these hackathons? So the hackathons, the DARA Big Data hackathons, are not hackathons in the traditional sense where you would bring together individuals who already are equipped with these sort of skills to solve some big problem. It's rather more like a workshop. It's an educational event where we aim to provide exposure to things like data science and machine learning by having students work on projects, interesting projects that are in astronomy or that make use of real-world data. And the idea is to boost students' confidence in being able to maybe apply some of these skills to their studies, like I said, or further their education in these areas. Or for young professionals, of course, to apply this in their own careers. So most of the projects that have already been developed are either development related or astronomy related. An example of a development related project is where satellite image data was used from the Sentinel satellites to determine the amount of flood damage caused after Hurricane Maria made landfall in Puerto Rico. We also now have image data for Mozambique, which will be running in a hackathon next year. And astronomy-related projects, which I'm sure many of you could think of a few machine learning-related astronomy projects, but some example is classifying galaxies by their morphology, so radio galaxies, FR1s, FR2s, for example. And for students who who haven't had exposure to astronomy, these projects can be used to the intrigue of astronomy is useful in then piquing their interest also in data science and machine learning. So the current model of the hackathons which we run, the projects are aimed at the level of postgraduate students and young professionals who have at least some level of Python experience. Even if this is very minimal, it's all right, but just we require that they have some experience with Python. And the hackathons are usually made up of about 20 to 40 participants. We try and provide prep material a week or two before the hackathon, so that students who are not familiar with the concepts, in the projects that they'll be working on, can gain some context, and also just pick up or make sure they have the basic skills necessary, like working with Jupyter notebooks, for example. As I mentioned, the computing infrastructure is provided by IDEA through their research cloud. Participants are usually grouped into teams of 4 or 5, and they take on the hackathon in teams, which they've come to enjoy because it's less intimidating, especially if they've not been to a hackathon before or been exposed to things like data science and machine learning before. They feel more comfortable taking it on as a team and learning from each other. We also make sure that ample tutor assistance is provided. So we try and have a ratio of at least 1 tutor for every 2 teams during the hackathon. And the current format of the hackathons is over two very intense days of programming for the students. during the first day, students go through tutorials which we've put together, which contain all the skills that they'll need in order to attempt the hackathon task on the second day of the hackathon. At the end of the second day, they give presentations as teams, and prizes are awarded to the top 2 or 3 teams. So these are some pictures from some of the hackathons that have been held previously in Botswana in 2018 and Namibia in 2019. In Botswana, they worked on they had an option of 3 different projects, or I think they were assigned to various teams. Image classification, they had to, and another one was that they had to build a movie recommendation app, and also to build a music classification system like Spotify. Good variety of different projects. And the hackathon held in Namibia focused on one project, an astronomy related project, where they had to classify signals as being either terrestrial, so RFI, or from pulsars. There was also a hack that was held in Madagascar in 2018, which I've not included on here. So obviously this year we've not been able to hold these hackathons in person as we usually would, and we've had to adapt and move them online. There's various pros and cons to this. The obvious con is that we're not physically present with the students in order to assist them and share our enthusiasm for the projects and the field. But the pro is that these hackathons are now less costly to implement. And if you hold hackathons fully online, you could roll out, many each year and reach more students potentially. We've so far come up with 2 possible models of holding hackathons in this time of COVID-19. One is where the hackathons are remotely hosted, so students are physically present at the institution with maybe a few tutors, maybe 1 or 2 tutors from the institution, and as well as their lecturers, etc. And the other model is where it's fully online, so yeah, everyone is connecting virtually. There's pros and cons to both these models as well. With fully virtual hackathons, students would, they'd be limited to students who have access to laptops and good, fast internet connectivity outside of their institutions, which in places like Africa especially is sometimes quite difficult for them to come by. However, it's safer in terms of COVID-19. And for remotely hosted hackathons, we've seen that it's been quite challenging in terms of needing people there who are on the ground, who are able to do or willing to do a lot of the organization and running around and prep to make sure everything is in place for students who are attending from the institution. We've made use of things like Slack and Zoom in order to communicate with the students and assist them during the hackathon. So especially Slack for the tutors, but Zoom has been less effective because it takes a lot of bandwidth. So in some instances, we've now need to use WhatsApp and WhatsApp groups to chat with them or send voice notes, or trying to make it work in various ways. So the next step is to develop for all these different models, to develop requirements and best practice guidelines to be able to enable global rollout of these kinds of events. A project that was developed, a hackathon project that was developed this year was around COVID-19. So it's in the field of natural language processing, NLP. So in this hack, students collected data from Twitter, from whatever region in the world they chose, and the data was COVID-19 related, and then they used machine learning in order to perform sentiment analysis on these tweets and gain some insights into various topics around COVID-19, such as maybe people's sentiment towards wearing masks or reopening of schools, etc. In this project, we also made use of something called transfer learning, which is a technique that allows you to achieve very good performance in terms of machine learning when you have very little labeled data available, which we did. But thanks to the rest of the OAD team, who painstakingly read thousands of tweets and manually gave them sentiment labels, making this possible. But with transfer learning, we're able to obtain really good accuracy still. And it's good to note that transfer learning is a technique that's being used currently in NLP to obtain state-of-the-art results. So that's really good to give students exposure to something that's being used in NLP today. So our first attempt at a remotely hosted hackathon was at the University of Zambia in early October this year. We had about 24 participants. Unfortunately, only 6 of which were female. But if you see on the bottom right picture, that's the winning team, and you'll notice 3 of them are female, which is great. Students were very driven, even though it was remotely hosted, and there was some issues such as connectivity, especially when it came to students giving their presentations, because they're presenting to those who are physically present, but also to the judging panel who were connecting remotely. This proved to be a bit of an issue. There was also overuse of the 2 tutors who were physically present, because it was just a lot easier or more natural for students to just put up their hands and ask for assistance, rather than making use of the other 4 or 5 tutors that were available over Slack to assist remotely. Students, even though they were undergrad students who had just very minimal Python experience, they were able to produce results. They had very interesting research questions around people's feelings towards vaccines, as well as one team even looked at how COVID-19 has impacted the economy in New York. So very creative, and they gave excellent presentations. So a successful first attempt overall. Now these are just some of the feedback from some of the students about Hackathon as well. So some of our upcoming events, we'll be holding a hackathon which will be fully virtual in the beginning of December. And it's as a pre-workshop event for the 4th African Space Generation Workshop, which is going to be held in Ghana next year in February, which may be moved online, but currently planned to be a physical event. So this is in partnership with the SGAC, and it's open to all African countries. And the intent is that each team would be made up of people from different African countries, allowing them to network with each other and meet new people, and work with new people from different backgrounds and different skill levels. The winning team for this hackathon will receive flights and accommodation to attend this workshop in Ghana next year, if it is held in person. For the actual workshop, they will have a big data and astronomy working group, and we will be holding another hackathon within this workshop, which will be a SETI-related hackathon. And for this project, we've been working in collaboration with the Breakthrough Listen team from Berkeley, and it's an older project that they had done where they observed the Voyager 1 spacecraft, but recently it's been reobserved in the mode in which they currently observe their targets. So Voyager 1 is the farthest man-made object, and it was launched in 1977, and they observe it using the Green Bank telescope and are able to detect it using the normal, in a blind search in the normal pipeline that's existing. You can see an image on the left there showing the detection of Voyager 1. So what's happening there is that the method they use is an on-off approach where they point at a star and point away, and they do this 3 times. So the idea is that if it's a signal of interest, it should only show up on the on observations, whereas RFI would be present in all of the observations. Another hackathon that's being planned for next year sometime is a all-female hackathon, which will be held in Mozambique. And this will be around breast cancer, so promoting breast cancer awareness as well, and will be a tumor detection project. So finally, what have we learned in order to build now on these models for these hackathons? Well, firstly, we've decided to have a 2.5-day sort of format where we have a dedicated sort of opening afternoon dedicated to presentations from people on the judging panel or the organizers, so that it doesn't eat into the students' hackathon time, which is already quite intense. We will also be inviting industry professionals to join these hackathons and give presentations so that students get some idea of how these skills are applied in industry. These guests will also sit on the judging panels. And in cases where we have remotely hosted hackathons where students are physically present, rather than trying to assist as tutors remotely, we've decided that we will train various sufficient tutors from the institution who will then be able to carry out these hackathons independently, even in future, which would be great for the institutions. We'll also be providing some equipment such as headsets to existing DARA computing suites to also aid with further events like the hackathons. In terms of the presentations, which were quite difficult in our University of Zambia situation, we've decided to also ask students to present sort of a report, so encouraging report writing so that we at least have something to assess if all doesn't work out in terms of connectivity. Also, to compensate for not being physically present with the students, we've decided to have an Ask Me Anything session at the end of the hackathon once presentations and prize giving is done, so that students are able to network and interact with organizers and people on the judging panel. As I mentioned, we have very few females, at the University of Zambia Hackathon, and this has been a consistent trend. Unfortunately, at hackathons, it's been not more than 20 or 30% of students who've been female. And so holding at least one all-female hackathon per year, we hope to reach more female students this way. And lastly, we're going to look into partnering with existing organizations who are currently using data science and machine learning to aid development. An example is WWF site, and they use satellite images in order to monitor various conservation efforts around the world and monitor things like deforestation, for example. So possibly partnering with them to create a hackathon project or a separate sort of hackathon where we try and solve some problem. Or working with a local organization like CodeBridge, which is a community of programmers, data analysts, and others who come together to work on projects that impact societal change. So thank you very much. And if you'd like to get involved with these hackathons in any capacity, be it tutoring, or if you have ideas for hackathon projects, or in fact, if you'd like to assist with hosting a hackathon at your institution, please feel free to get in touch and visit the hackathon link on the OAD website to find out more. Thank you.
Thanks very much, Nikhita. That was great. Are there any questions? Anyone would like to answer a few or ask a few questions? I think Nikhita can answer them. Maybe whilst people are thinking of stuff or putting their hands up in the chat, what, Nikhita, are the sort of minimum requirements you would need to participate in a hack? Do you need a fast computer or anything?
Well, not really. So luckily, having access to Ideas Research Cloud facility takes care of that part, as the tutorials are all loaded on their platform where we have their computing resources available. So all that's really required is a laptop and access to a good internet connection, especially more for interacting with those who are assisting remotely rather than actually running the hacks, although that does require a good connection, but it's not as intensive as using things like Zoom and to interact with us, give presentations. So yeah, if it's fully online, those are the only requirements. That they have some experience.
Thanks, Nikhita. There's a question here from Tawanda.
Okay.
Hi, Nikhita. So I just wanted to have a feel around what is the sort of composition or the proportion between, or the split between, for example, students from social science or business and students from the physical sciences, because you rightly mentioned that the many of the students which we had made from the Zambia hackathon were not necessarily very glued up with respect to Python competencies, programming competencies. So if you can tell us the splits, and also would you agree that perhaps there is an opportunity to also involve the broader sort of mainstream, because some of the development business challenges against which we can use some of these coding skills are actually like social, can be found in sociology, economics, and so maybe if you can just give us your comments regarding that. Thank you.
Yeah, sure. So at past hackathons, students have all been, in science fields, either computer science or physics or astronomy students. I'm not aware at the previous hackathons if there was anyone outside of the sciences, but I guess the limiting factor is always that they need to have sort of some experience with coding. I don't think it's, I mean, although we do add a lot of, explanations and comments to the tutorials, the code in the tutorials, I do think it would be quite difficult for someone without any programming experience to take part in these in the current model of these hackathons. However, I'm sure we could develop things where a more prep material is sent out. If we are targeting people from social sciences and other fields to specifically when projects are development related, it's definitely something we could do or think about how to give these students some way of participating without having programming experience.
Thanks, Nikhita. Any more questions? Feel free to unmute yourselves and ask.
So Nikita, you give training for all age groups of students or graduates, masters, which level you consider?
So yeah, the hackathons are, because they make use of things like machine learning, it can be quite intense. They're aimed at students at the postgraduate level, but it can definitely work with undergrad students, as most of the students at the University of Zambia hackathon were undergrads who just completed a very basic introduction to Python course, and they were able to really excel. So I think, yeah, for now it's been aimed at university level students, and I think if you're targeting school going students, it falls more into the duties of the Office of Astronomy Education rather than the OAD as well. So yeah, we haven't. Those are the students we've targeted so far.
Thank you.
Thanks, Nikhita. Anyone else? Well, if there's no other questions, I'd just like to thank Nikhita again for telling us all about that. You, of course, know where to find her if you have any further questions. And then just to let you know that we've got Tawanda and Amadou who will give us the colloquium next week. And if anyone else is keen on discussing their research, we still have an open slot on the 10th of December. So that will be our last colloquium of the year. So please do get in touch with me or Jessie or Zara if you're keen to give a talk. So thanks everyone, and bye.
Thanks. Bye everyone.
Thanks, Nikhita. I think that went very well.
Okay. Cool.
Well done.
Thanks. See you.
See you. Bye.